Today's episode is about process discovery, letting the agent's behavior draw its own map. So, to recap the previous video, we have our logs here. These are the different runs from your agent, and this is the model that we extract from there. The problem is that, as we have discussed in the previous video, is that they are coming from each other. So, it's a circular problem, because if you have a problem here, you will not be able to detect it through this one, and the fitness score is gonna be non-significant. So that's the setup. Watch the previous video, please, if you don't get it. So this is how it used to happen before. They used to use DFGs, and it was the standard for the de facto side. So we have the following DFG. If you don't know what's a DFG, you could check my inductive miner video. I'm explaining what is a DFG, what is the inductive miner, why we decided to use the inductive miner instead of DFGs. And what you can see here is that you have what could be, what you could think was a loop. But the truth is that none of these activities actually ran twice. The reason why we have these connections is that we actually have concurrency or flexible order. Some activities could come before and some could come later. All of these you could check with more detail on my inductive miner video. Now the issue is that you as a user, let's say you have the following log, you have 500 runs with ABC, you have 500 runs with AC, and one of the things you could do is that you could filter out the runs that had B. So at the end of the day, you would receive the following report. It would tell you, hey, from A to C, you have 50% of the runs that are reaching A to C in 10 days, but the truth is different. So I don't know, so I need you to focus on this point. So what's happening here is that the cost of B, the cost of the activity B, is baked into here. And you could think as a user is that, okay, A to C reaches 50% of the time for 10 days, but that's not the truth. And all of these issues have been discussed in this paper from Van der Aalst from 2019. So all I want you to remember from all of this is that actually DFGs should not be used as a de facto standard for us. So one information I would always want you to remember here is that every discovered net overgeneralizes by design. So this was a paper from Leemans, Van der Aalst, and Buys. I hope I'm pronouncing that correctly. What they discovered basically is that the concurrent blocks, the loop blocks, they always have this problem. For example, for concurrent blocks, they are accepting all interleavings. The loop blocks, they are accepting unbounded repeats. So, and these are traces we never saw. This is the point of overgeneralizing here. So here, there is one number most of the people are misreading, which is the variance. A variance is a distinct activity sequence that runs are sharing. So runs that follow the same sequence collapse into one variant. So for example, if you have a deterministic workflow, if you have a sequence of events that are happening and it's almost very clear that you have the sequence that will appear in your logs, those will collapse into one variant. The issue is that our agents by nature, they are stochastic. So there is a spread of non-determinism. And for example, this is just a number that I'm inventing here. For example, 50 runs of 50 different agents could produce 50 different variants. That's a lot. 50 different variants for 50 runs is a lot. It's not something you want to analyze because basically your data is too varied. So I actually wanted you to see this visualization. So here you have what the log did in blue. So this is what your agent actually did. So all in blue. In orange or whatever is what you defined as the norm, what should happen. The overlap is conformance, is the part where both are conforming, as in the log is doing what the norm wants the norm to do. The left side, so this is the part without the conformance side. So it's the deviations, the log moves, and in alignment terms, this is what we call a log move. So this is the whole point of mining. The right side is paths that you decided in your happy path that were allowed, but your agent never took. So this is all the part that we're talking about. And we could call this region an untested norm surface. Now, the interesting question that this paper from 2015 is talking about is this misbehavior as this part. Is it misbehavior, or does this mean your norm is incomplete? As in, should my orange be like this, like bigger, and then, for example, like this, and more parts of this will be, of this blue side will be included in my orange side? So, and that's the question that was answered by the following paper. Is a deviation misbehavior or an incomplete norm? Deciding and folding good behavior back is model repair. So this notion of model repair is also very important. We will talk about this later on. So what often happens is that everyone is filtering before discovery. What happens is that you have your 80%, this is 80% of your data, and you have here your 20%. And what you're gonna do is you're basically keeping your top K. You're keeping your top 80%. And this makes your map cleaner, your analysis cleaner, but the tail, this part, is deleted. And it is exactly where compliance and performance problems live. So this is where the rare, weird runs are happening in this tail. So Van der Aalst, Professor Van der Aalst actually flags this directly and he says that it's the non-mainstream runs that create these problems. So there is also a paper that discusses the premise of a paper in 2017, and it is about the premise of deviance mining. So this is also a paper to check out. There are three calls. These are three functions. You have the following that gives you the map, the following that gives you the net, and the following that gives you variance for the spread. You can have all of these signatures. You don't need to remember them actually today. This is done basically this check is done by AI. So yeah, maybe you could know it for general information, but it's not very useful. And these signatures are stable, so for this release. And that was my last slide for today. Now, to give you a recap, so we discussed three things. First, how we had our DFG, how the net is lying to us by generalization, how when you have perfect fitness and you could still have low precision, so it's still another problem, and how variants are your non-determinism dial. The one line to remember is that a discovered map shows what your agent did, never what it should do. This should do is a very important thing that you need to figure out as an engineer. This is done with BPMNs, with nets. This is something that you can only know through your requirements engineering, and then you can do model repair. But this is not something you could teach. This is something case by case. So next up, we'll talk more about conformance checking. And if you liked my content, please like and subscribe, and follow me on LinkedIn. Thank you.